Welcome to my presentation on quantitative methods, D2. My name is Professor Tailoka, and I'm going to take you through the common mistakes which you make in quantitative methods, and at the same time give you some examples on how to correct those mistakes. Now, on my first part, the most common mistakes you students make when it comes to compound interest, it's failure to use logarithmic method to solve for the value of t or the interest rate r. The next part, you have a problem in terms of calculating the measures of location and dispersion from grouped data. Again, you have got a problem in terms of time series when it comes to isolating the components of seasonal variations. The other mistake which you make is in terms of using the Z distribution. Failure to correctly use the Z distribution tables to get the required probabilities. Then lack of understanding of the required concept to solve the maximum and the minimum regret criteria. Now, when it comes to compounding, that is interest, in financial mathematics, you have the formula for compound interest, where you have got P with the subscript that is T, which is the future amount, equal to, you have got the initial amount, which has got P naught, and inside the brackets you have got 1 plus R raised to the power T. That is our compound formula. So we have got time, interest rate, which are unknown, and you might be required to find either time or the interest rate. Let us look at an example, which is example 1. In A, find the compound interest rate required for 5,000 to grow to 60,000 in 6 years. The second question, a bank pays 8% interest rate compound annually. How long will it take for the 50,000 to grow to 60,000? Now, in the first question, we are calculating R. We are given the initial amount, which is 50,000. And we are also given the future amount, which is 60,000. We have to find that is R. Substituting in the formula, you are going to get that is 60,000 equal to 50,000. Then inside the brackets, you have got 1 plus R to the power that is 6. Now, how do you go about finding that is the interest rate? So you are going to divide both sides, okay, by the initial amount so that you get 6 out of 5, which is equal to the right-hand side. Now, the trick part of it is to get that is the interest rate, which is trapped inside that is the brackets. In part B, we are required to find that is a T, which is again, the initial amount we are given is 50,000. The future amount is 60. And we are also given that is the interest rate, which is 8.5%. Now, how do we find that is the time? Substitute in the given formula all the given values, okay? And again here, you are going to end up with an expression 6 over 5 equal to, that is, inside the brackets, you have got 1.08 to the power that is T. How do you solve for T? This is where it requires a student to use logarithm. Now, in most cases, we forget about natural logarithm. Please practice on this one. Take natural logarithm on both sides. And it will give you T equal to natural log 1.2 in the numerator divided by natural log 1.08 in the denominator, and it will give you 2.23488. But give your answer to those decimal places or one decimal place. Now, the most interesting part is that your calculator has got all those things inbuilt. Use the calculator to get the natural logarithm of 1.2 and the natural logarithm of 1.08. Now, we look at investment appraisal. Investment appraisal requires you to assess the value of the project. And here we have got two methods which we use in this course. One is the internal rate of return. Two is the net present value. The net present value involves the cash flow. It will give us the difference between the cash outflow minus the cash inflow to give us the net present value. The internal rate of return is just the point at which the net present value is equal to 0. Now, when you come to the example, let us say you put in the project 20,000 kwacha. And this 20,000 kwacha, at the end of the day, will bring in 25,000 kwacha. That is in 3 years' time. Then the question is, use the net present value and the internal rate of return to decide whether the investment is worthwhile if the prevailing market interest rate is 6.5%, which is compounded, that is annually. To the amount at present. So we make P naught the subject to give us, that is, PT equal to P naught. Inside the brackets, we have got 1 plus R to the power minus T. And we substitute in those formulas where we are given the initial amount, which is 25,000. We are given the amount at T, which is 25,000. If you substitute in the formula with T equal to minus 3, it will give us, that is, the future amount, for instance, will come to 20,696 kwacha 23 ngwe, minus the initial amount which I had put in, which is 20,000, which will give us 696 kwacha 23 ngwe. The net present value which you have got is a positive value. So it means the investment is worthwhile investing. If it was negative, then you know to say your investment was not worthwhile investing. Again, as a student, what you should understand is that if the net present value, in our case, you have got two projects which you are comparing, and you get positive values, choose the larger value. The larger value is the one which will give you better investment. Now, when you come to internal rate of return we are saying it's at a point where the net present value is 0. So substitute in the formula those values, which will give you the value at 0. If you go to the formula, the future amount, that is 25,000, the initial amount, which was 20,000, and you are going to have your R, which is an unknown. At that time, it's like you are breaking even point. At that point, you are going to get the exact value, which is 25,000. What value of R? That is the point at which the internal rate of return makes the NPV to be equal to what? To 0. Now, here again, the problem is to solve for R, which is trapped inside the brackets. Now, how do we solve for that R? You have, for instance, x squared equal to 2. How do we solve for the value of x? So we take the square root on both sides, which will give us x equal to square root of 2. We do the same thing with our formula which we have here, where it is to the power 3. Take the cube root on both sides, so that it will give you, that is, 1 plus r, which will be equal to 5 over 4, but raised to the power 1/3. Again, my students, it's very important. These things are not complicated. Use a calculator. The calculator will help you to get that value. On the calculator where there is a heart on your calculator, there is square root there, the radical to the power x. Where there is that x, put 3 on that calculator. It will give you the cube root. Some calculators have got the cube root. You will get it. Others don't have the cube root, but they have got the radical to the power that is x. Where there is that x, put a 3, and it will give you the cube root. In our case, we got 1.07. So we make R the subject, and it will give us, that is, 7.7%. Now, what happens is that the market rate is 6.5, but your internal rate of return is 7.7. So what you are being told is that, where should you invest your money? Should you put your money in an account which will earn you interest of 6.5, or should you put your money where interest will be 7.7? So you go for the larger one. So since the internal rate of return is greater than the market rate, which is 6.5%, it's better for you to invest in the project. So we say here the project is worthwhile. Now, when it comes to time series, any data which has got a time element embedded in it is time series data. Now, you students in this course, you are required to deseasonalize data. That is to find the seasonal components in the given data. Now, there are two methods which you can use. One is the additive method, where our actual values, or y, will be, or the trend value will be equal to the trend value plus the seasonal variation. The t is the trend value plus the seasonal variation, which is s. That is the additive model, y equal to t plus s. The second model is what you call the multiplicative model, where you have got your y equal to trend or t, but times the seasonal variation, which is s. You have got those two models, and those are the questions which comes in. Now, when you are required to find that the seasonal variation using the additive model, you just make s the subject. So you make s the subject, then s will just be equal to y minus t. That is the seasonal variation for the additive model. For the multiplicative model, you make s the subject. So you divide both sides by t, and your seasonal variation becomes y over t. The t is the trend. Now, let us look at the example which we have. From the following data, which shows cost of production forecaster, PLC, for a 3-year period between 2015 to 2017, obtain seasonal variations using the method of moving averages. And we are given that data, which is there. The 776 is supposed to be, that is 76.
So just repeat that.
The 776, I've seen the 776, supposed to be 76. Now, in this question, we are supposed to use 1, the additive model, B, the multiplicative model. Now, we start with the additive model. And we are told to use the method of moving average. Now, where you have got an even number of moving average, that is it, if the moving average is 2, 4, 6, or 8, we use what they call centered moving average, because the value does not fall on the actual data given. If it's an odd number, 1, 3, 5, 7, the value what we have is clearly a moving average, because the value falls on the actual data. Now, we compute the what we call the 4 moving totals. In my case, the way I go about, so that you don't make a mistake, I start with the first value. I write them 8, 88, like in our case, 76, 94, 88, 76, 94. You add those to get that is 355. You drop the first value, add the second value, you get 88. You have dropped that to 97. You get 88, 76, 94, 101. You continue doing that up to the end, because you are going to lose the first 2 values and the last 2 values. Then when getting the centered moving average, you add 355 plus 359 and divide by 8. Why by 8? It's because the total number which has gone into that sum is 8. You can remember to say you have got the first 4 plus another second 4. 4 plus 4 is 8. That's why we are dividing by what? By 8. Similarly, for the next one, you have got 359 plus 368. The total divided by what? By 8. Similarly, 364 plus 367, the total divided by 8. So that is how we have got 97, 88, 76, 94. Now, all what we do is we need to center them, okay? We need to center them. These are the actual observations. We need to center them. That's how we have got 89.25, 90.37. These are the now centered moving average. What I was explaining at first was those were the moving totals, and when you divide by 8, you get the centered moving average. Then you subtract the initial or the actual observation minus the trend value or the centered value to get the seasonal what? The seasonal variation. So we are subtracting y minus trend, which is t, to get the seasonal variation. Now, you would see that the quarters have got different values. The quarters have different values. The first quarter in the first year, that is 2015, the value in the second year, that is 2016, in the 2017, the first quarter, second quarters have got different values. But we want a single value for the first quarter, a single value for the third quarter, a single value for the fourth quarter. So what we do is we divide by what? By 4. That's why we have got the total variation. You divide by 4 to give you 10. In second quarter, you have got the total variation, 0.37. You divide that what? By the number which has gone into the total, 1, 2, 3, you divide by that. Similarly, you go to the third quarter, you have got those two values. The total will give you minus 27. You divide by what? By 2. Fourth quarter, you have got 3, to give you 7.25. Divide that by 2, it will give you 3.625. That gives us the average seasonal variation. The only problem is that if you have deseasonalized your data, if you add those average seasonal variation, the sum is supposed to be what? Supposed to be 0. If you don't get a 0, then you adjust. That is how the adjustment comes in. Adjusted seasonal what? Variation. It's because you have divided by 4, and then when that value, the discrepancy which comes in, is not equal to 0, whatever you divide it by 4. That value, if it is positive, then to those seasonal variations, you are going to add the negative value to it. That is what you have done. If you see where there is adjustment, the values are negative. We got a positive what? Average in terms of seasonal variations. That is what is adjusted and added now to the average seasonal variation to get the seasonal variation adjusted. That one, if you add it, it will give you a value that is 0. Then that means you have deseasonalized your data. That is using the additive method. And this is what is being explained very clearly now in this slide, where you have got the average seasonal variation, which is supposed to add to 0. And that is where we have divided that by 4. We have got the positive value, which we have changed, if you remember what I did explain in the area slide, to the negative value. Now, when you have got that is a multiplicative model, the 4 centered moving average are just the same averages. The only difference is how you arrive at the seasonal variation. In this case, I was saying the seasonal variation will now be the actual seasonal variation will be now the actual values, which is the y value, but divided by t, which is the trend values. So that is how we have got those 0.85. You are dividing 76, you are dividing it by 89.25 to get 0.825. That is how you come up with the seasonal variations when the model is a multiplicative model. Again, because we have got different values in the first quarter of 1915, first quarter 2016, first quarter 2017, we have got different values. We want a single value to represent the first quarter in 2015, 2016, and 2017. We want a single value. So again here, we are going to find the average seasonal variation. Now, when you add the average seasonal variation, since there are 4 quarters, and this is a multiplicative model, they should add up to what? To 4. Okay? They should add up to 4. So that when you divide 4 by 4, it's supposed to give us, that is 1. And this is explained, that is in the next slide. In the multiplicative model, as I was saying, the average seasonal variation should add up to what? To 1. Now, the next common mistake which we face when we are marking with you students is on the max, and also the min-max regret criteria. This comes under decision making with uncertainty. Now, when you look at max criteria, it has got 3 phases. In one, you choose that is the maximum of the payoffs. That's what you do in the first one.
Take your career prospects to the next level with Zika.
Our diploma in accountancy is an essential qualification if you're planning on entering the accounting profession.
The Zika tax program at both certificate and diploma level equips you with an enhanced understanding of the field of taxation.
Our diploma in public sector financial management is ideal for accountants or trainee accountants working in the public sector.
And CA Zambia, a respected designation designed to ensure that graduates are highly trained to hold senior positions in the workplace.
You can study through flexible options like self-study, as well as part-time or full-time through our accredited tuition providers.
Zika sponsors the top CA Zambia graduate to the One Young World Summit for Young Leaders and also offers scholarships to the top university accountancy graduates from recognized universities.
Visit zika.co.zm now for more information or find us on Facebook and LinkedIn.
Don't delay, your future awaits.
2, you go after you have picked up the maximum of the payoff. Again, you choose the maximum of the payoff. That gives us the what? The required alternative course of action. Now, when we look at the max mean regret, how do we go about with the max mean regret? See, the table of payoffs which we are given, we have got the state of nature. It can be either on the column side or on the row sides. But the state of nature cannot be changed. It is by nature, it's there. Then on the other side, we have got the course of action, which you choose, the course of action. Now, when you are using the min-max criteria, you look at the table of regrets. How do we come up with the table of regrets? Now, the first thing we do is look at the state of nature. And I'm emphasizing here, look at the state of nature and ask yourself, what will be the maximum payoff in the state of nature? Considering now the alternative of actions. If you choose the maximum payoff, then you subtract from each and every, that is course of action, to arrive at the regrets in that column. Go to the next column. Do the same thing. Look at the maximum, okay, payoff under that state of nature. Then go again, we are looking at the column here. If the state of nature are in the column, you are looking at the state of nature and ask yourself, where is the maximum payoff? Then look at the course of action. Subtract the maximum from each course of action to give you the regret. Then after that, you look at the what? The maximum regret. You choose the maximum regret and you want to minimize now the what? The regrets. So it's like minimizing the worst action or the worst payoff. Minimize it. That is the min-max regret. Let us look at an example. You are a businesswoman has 3 alternatives open to R, of which can be followed by any of the 4 possible events. The conditional payoffs in Quacha for each action, event combination are given below. Determine which alternative should the businesswoman choose if she adopts the max criteria, B, min-max criteria. When looking at the max criteria, the best course of action is action 2. Now we go to B. Construct a table of regrets. The maximum for each event, if you look at the regrets, for W, it will be 15. X, it will be 13. Y, it will be 19. And Z, it will be 9. Then we subtract from each and every row to get, that is, our table of regrets. You will see that for W, when the state of nature W is, and we subtracted the 15, we got 6, 18, 0. Similarly, for X, those are the regrets we have got. Now, what you ask yourself is that, what will be now the course of action under that? You look at the maximum payoff along the course of action. That's how we have come up with it. 28 for action 1. We have come up with 18 for action 2. We have come up with 17 for action 3. Now you minimize the maximum regrets, and you'll see that the minimum is 17. And that's how we end up choosing the course of action as 3. The next common mistake which you as students make is on the calculation of the measures of central, location, and dispersion. Now here, where the confusion comes in is on the issue of the lower class boundary and the lower class limits. The distinction between the two, the limits and the boundary. The class boundary includes all the observation in a given interval. But if you look at the class limits, the class limit does not include all the observations in the given interval. Now, let us look at the example. The lengths of 50p ponds were measured to the nearest centimeter and grouped as shown. Estimate the mean length, giving your answer to 1 decimal place. We have got that table where we have got 5 to 9. Those are the class intervals. And below, you have got the associated frequency. Now, when you come to the solution, the 5 to 9, which we are given in that question, that is what you call a class limit. The 5 to 9 is what you call a class limit. So we find the class boundary for our class limit. That means since what we have is a whole number, from 5 we are going to subtract 0.5 to get 4.5. To 9 we add 0.5 to get 9.5. Now what we are given there, what we have come up now, that is what you call a class boundary, or the bounded class interval. So when you divide that by 2, it will give us the class middle point, or what they call the class mark. We do the same for the other class intervals. If you look at 10 to 14, those are class limits. So we get the class boundary. 10 to 14, 10 minus 0.5, it will give us 9.5. 14, you add a 0.5, it will give you 14.5. That gives you a class boundary. If you add the 2 and divide by that is 2, it will give you 12. What you get is a middle point. Then if you multiply, that is the 7 and 5, it will give you 35 to get the fx. You multiply 12 and 6 to give you 12. 12 by 6 will give you 72. You continue multiplying and then sum up the summation of all the observations. We had 50. Then if you sum up the total, that is f times x, it will give you the 1025. So the mean which we are looking for is summation of fx over sum of f. The 1025 over 50, which will give us 20.5. This is where we were using, that is, the class boundary. Alternatively, we can use that is the class limit. If you are using the class limit, you don't need to subtract the 0.5. Just add the 5 plus 9. In this case, it will give us, that is 14. Divide that by 2, it will give us 7. Again, it takes us back to when we are computing the mode. It's the same mistake which comes in, because the mode uses the lower class boundary, and the lower class boundary is affected by either using the class limit, the lower class limit, or the lower class boundary. But whichever you use, just be consistent. Use either the class boundaries or use the limits. The only difference will be there is the plus or minus 1 error. Now, the other thing which I wanted to talk about is, it's just the values A, B, and C. Your A is the frequency below the highest frequency, which is B. And your C is the frequency below the highest frequency. The A is the frequency below the highest frequency, and the C is the frequency above the highest, that is the frequency. Now, from our question, we have got the lower class boundary where the mode lies, because the highest frequency is 15. It lies where we are at the 20, okay? So you subtract a 0.5 to get the 19.5 as the lower class boundary. And when you substitute, you get 19.5 plus, that is 2.5. Alternatively, if you are using the class limits, you are going to use 20. But the answer which you are going to get, like in our case, we got almost the same what? The same answer. It doesn't mean to say it will always be the same answer. No. But there might be a plus or 1 error bound. What I'm explaining is that the answer you get when you use the class limits and the class boundary will be the what? Will be the same. The only difference is that, see, when you are using the class boundary, all the data is considered. But when you use the class limit, okay, you are losing some of the values. That's the difference between grouped data and ungrouped data, okay? When you use that is grouped data, you lose certain information. But when you use ungrouped data, you are using the actual information. You don't lose what? You don't lose anything. The other topic where you as students make a lot of mistakes is on regression and correlation analysis. The advantage is that you are allowed to use a calculator. And the calculator has got statistical formulas in it. So I would encourage you to use the what? The calculator. Let us look at this example. A sample of 8 employees is taken from the production department of a car factory. The data below relate to the number of weeks experience in the production department and the number of cars which were rejected as unsatisfactory last week were as follows. You have weeks of experience A, 3, and the number of rejects, let us say 16. For B, it's 4, the number of rejects, 17. Now, the question is, calculate the coefficient of correlation for this data and interpret its value. That's A. In B, find the least square line of rejects on experience. Predict the number of rejects you would expect from an employee with 7 weeks of experience. Now, you go to the calculator, this simple Casio calculator, okay, which is FX82MS. Place that is mode. It will give you that is comp 1, standard 2. Then you are going to have that is regression 3. Place that is a 3. It will take you to linear 1, log 2, exponential 3. So place the 1. It will take you that is into regression. Now, what you do is to enter the pairs of point. Place that is a 3. Then come here, there is m plus a, and there is a comma. Place comma a. Then place the number that is 11. You have got 1 point, which is 3, 11. You have got a point 3, 11. Then place m star here. Then it will take that number in, and it will give you n equal to what? N equal to 1. You have got 1 observation in. Go to the next observation, okay? If you place that is 4, you come to 4, then you place that is the comma, and you place that is 17, 1, that is 7. Come again to m plus, place m plus, it will give you 2. That means the second observation has done what? Has gone in. So you can continue that format, okay, until all the 8 observations are what? Are in. And it will give you n equal to what? N equal to 8. Now, when you do that, the calculator gives you all the values which you need in order for you to compute, that is, the summations, x, yx. When you place that is the mode, okay? And down here, you will see there is sum of squares, there is variance here. That is where those summations are coming in. Place the shift key here and the S sum. Place the shift key here and the S var down here. It will give you the summation of x squared, x, y squared, y, and the product of xy. So all what you need to do is, you don't even need to use the formula which is there. But if you want, you can use it. But the same calculator has calculated for you the error value. So if you shift your key and the S var, and place the cursor key which is here, and place the cursor key which is here, it will take you to where the error value is. And in our case, we got minus 0.871. And since this value is close to 1, we can say there is a perfect but negative linear relationship. Again, when you go now to B, which is asking you for the least square method, this calculator of yours has computed the value for A, it has computed the value for B. Or what you need to go to the formula sheet and get is just the formula for the regression line. So if you place the shift key here, and the S var here, and place the cursor key here, it will take you to where the value of A and the value of B are. So this is the required least square line. Now, for the predicted value of y, just use the line which you have come up with. We are told x is what? X is 7. We are told that x is 7. Substitute it in the least square line. Where there is x, put what? Put 7. And it will give you 11.984. But if you wanted, you can still use your calculator to compute what? That predicted value of y for x equal to 7. What you do is, first of all, enter 7, okay? You enter 7 first on your calculator. Then press the shift key. Then you go to S var. When you go to S var, then you start moving this cursor key. It moves. It will take you to the last, and it will give you the value of what? Y. That value of y will be the same value as the value which you have got from the fitted what? The fitted line. The other common problem is on finding the probability using the Z table. And for the Z table, we have got two types of Z table. One is area under 1, which they call cumulative probability distribution. The other one is area under 0.5. This is where we start from. They are all positive values. There are no negative values from 0 to Z. And always the table which you have and the table which you use in this course is one which has got area under 0.5. But that does not mean to say the lecturer who is teaching you cannot use the area under 1. The most important thing for you is to understand and be in a position to use either the table. The answer will be the same. So if you look at example 7 here, using the normal tables to find the probability of Z being less than 0.75 or the probability of Z being greater than 7.5. Now, for less than 0.75, the area under the curve, 0.75 is greater than 0. So this value is on the right-hand side. Since we are saying the area less than, it includes the other half of the table, which is 0.5. The table will give you the area, which is 0.2734. So you add this area to 0.5. That is how we get 0.7734. Now, if you are looking at the area greater than 0.75, this one, it is on top, on the right-hand side of 0.75. It's on the right-hand side of 0.75. The table gives us 0.273, the area between 0 and 0.75. That is what is given by the table, but we want the area above that. So since it is under 0.5, we subtract 0.273 from 0.5. That's how we get 0.2266. Now, let us look at the next example. The time taken by a delivery man is normally distributed with mean 15 minutes and standard deviation 3 minutes. Estimate the probability of taking 1, longer than 19 minutes, B, less than 12 minutes, C, between 11 and 18 minutes. Furthermore, assuming the time is at most 5%, find the time the delivery man takes. If you look at this example, as I said, it's the area under 0.5. And when you look at the normal distribution, it has got two parameters, the mean and the standard deviation. So we are saying let X be the normal standard distribution, with mean mu equal to 15, standard deviation sigma equal to 3. Now we are looking for probability greater than 19. Along the column, it gives you to 1 decimal place. So along the column, you get 1.3. But on top there, the other 2 decimal places, 0.03, is along the what? The rows. On top, that is where that value is. 2 decimal places is on top. So 1.3 and 0.03, where they meet, where they intersect, they will intersect at 0.341. That's where they will meet, at 0.341. Now, since that is the area between 0 and Z, okay, which is 1.33, it is 0.314. We subtract it from what? From 0.5 to give us 0.0918. Now, when you are looking for the area or the probability less than 12, this is to the left. 12 minus 15 divided by 3, it will give you a minus 1. This area is negative. It is on the left. Now, you look at the positive. It is symmetrical. You look at the positive. So the table will give us the value between 0 and 1, which is equivalent to the area between 0 and minus 1. And that area is 0.3413. So you subtract it from 5 to give us the 0.1587. Similarly, when you are looking for probability of Z greater than 11, but less than that is 18, you are going to standardize the 11, which will give us that is minus 4 over 3, which is minus 1.33. Then when you standardize 18, you subtract, it will give us 3 over 3, which is a positive 1. So when you go to the table now, the area between 0 and 1, okay, plus the area between minus 1.33, you add those 2 areas. That's how we have got what? 0.749. Now, if you look at, for instance, probability of observing a value less than minus Z, this is generally what we are saying. For our question where we have been told that what will be the probability, okay? What time will it take for you to observe at least 5% of your observation? At least 5% of your observation. Now, if you look at 0.5, the area under the curve we are saying it's 0.5 this side, 0.5 this side. But if you look at 0.05, it is less than 0.5. So it is to the left. So it has got a negative value. So from that minus Z to where 0 is, we will subtract from 0.5 to give us 0.45. So you look in the main table. In the main table, you look where 0.45 lies. And it will give you the value 1.6 along the column, across here 0.05. Where it will intersect, you find that that area is 0.45. Or any area close to that particular value, in some tables you find it will be 0.405, which is close. But in this case, you take up, let us say, minus 1.6, because it is on the what? On the left. Then substitute that value in the Z-score. When you substitute that value in the Z-score, you have got minus 1.65, which is equal to X minus 15 over 3. Multiply, we are making X the subject. Multiply to make X the subject. so that you get x minus 15, which will be equal to minus 1.6 times that is a 3. And if you simplify, you get 10.05. It means that the time required is less than or equal to 20.05 minutes. My dear students, take this opportunity to go through the slides. Understand the material in the slide. It will assist you to correct the mistakes which you have been making for those who are repeating the course. But for the first timers, it will make life easy for you so that you pass the what? The course at your first attempt. Thank you for your attention.